Hello, grade 11s, and first off, just thanks for your feedback and pushing through this term. I know that it's feeling real now. It's been a full week, and this is it. This is the new norm for now. So, yeah, well done. And as I said, thanks for the feedback. I know one of the bits was I tried that more weatherman-y style yesterday, and it was a bit of fun, but maybe not all that appropriate. Not appropriate, but it will be useful at some stage. But working through the examples on the screen for you is also really, really useful. So please let me know that, because I think that's useful. And maybe just going through it slowly, methodically, rather than trying to rush through. And I just get quite excited, partly getting excited by the mathematics of just having fun with these setups and recording as well. So I'm going to run through 3 examples of finding the equation of the graph. And these come from the textbook. Remember, the textbook's on the website. And I think this is on page 139 of the textbook and on the website for the soft copy. Okay, so these 3 examples, and the last one, we're going to learn something slightly new as well. And yeah, obviously going to be a useful one. So let's run through these 3 examples steadily but surely. Find the equation of the parabola with the turning point 1, 5. So this bit here is our turning point, which cuts the y-axis at 0, 4. So there, that's our y-intercept. And now, when we're finding the equation, I know for the last 2-3 years you've been finding equations from the graph, and we're going to keep on the same type of strategy where we're going to do what we did in sketching it, but in reverse. And these two just work so nicely hand in hand, knowing how to sketch the graph, having a good picture of it, which is why we don't sketch by just doing the table method on a calculator, because then it's really difficult to find the equation. So let's say our parabola, we know we're going to have an x squared. And this isn't grade 10 where you just go y equals ax squared plus q. This time we know that one of the forms of our equation is y equals a x minus p squared plus q, where a, remember, a is stretching it, or if it's negative, it's reflecting it, and p moves it left and right, and q moves it up and down. And we saw, remember when we drew those parabolas to start with, that it seemed like there was a link with p and q in the turning point, and then it turned out there was a beautiful link that p is indeed the x-coordinate of our turning point, and q is the y-coordinate of our turning point. So we can plug in one bit straight away. We don't know what a is yet, but we do know something about these x's and q's. No, the p's and q's at least. Mind your p's and q's. Now, we said that the p always felt like the opposite. Like when it was minus 3, it moved it right by 3. And if it was plus 3, it moved it left by 3. So the same applies here. It's a positive 1 here. So it's going to feel like the opposite. We've got a minus 1 in here. P is actually the x-coordinate of the turning point, but it looks like a minus 1, and we've got a positive 1. That was that kind of opposite-y feeling that we had. Okay, then Q is quite easily, it's just the turning point y value itself. So this whole parabola's been shifted up, it's been translated up vertically by 5, so it's going to be plus 5. That we just substitute in straight away. Now our a value, we do know a little bit about our a value. We know that it should come out to be positive or negative. What do you think? It should be negative, right? Because it's a sad parabola, and our sad parabola is a negative a. How are we going to find out a? Well, we haven't used this point, and quite often it's useful just to substitute in the point. It's not like a straight line. We work out gradients or things. So let's just substitute this point. So I'm going to say, let's substitute the point 0, 4. Now it's right handy over here. I don't have to look back up to the graph and which one was x, which was y. So our y value is 4. 4 equals a. X value is 0. 0 minus 1 squared plus 5. Now we've got one equation and just one thing we don't know. So 4 equals 0 minus 1 is minus 1 or negative 1. Squared will give us positive 1. So that's 1a plus 5. Okay, let's subtract 5 from each side, which means that minus 1 equals a. Good stuff. It came out to be a negative that matches what we thought it would be. And some of your feedback are saying, you've got a sad parabola and the turning point's down there. It's good just to keep that in mind, to think, well, a should be negative. Okay, if it came out positive, we'd just check our working here somewhere. So from there, let's finish it all up and say, well, y equals a is negative 1, so negative, or let's just put the negative 1, x minus 1 squared plus 5. And there's our final form of the equation. Don't have to multiply it out, anything like that. That's a very valid form of our equation. And if you're asked to sketch that, you'd be able to sketch it. Because you go, oh, minus 1, it's like the opposite. It moved right by 1, moved up by 5. Everything kind of matches quite nicely. So that fits in nicely with what we've been doing so far. Let's move to the second example. The graph of y equals a over x minus p plus q is sketched alongside. Determine the values of p, q, and a, and hence the equation of the hyperbola. Cool, hyperbola. We've got our two asymptotes. It's almost like that point's really important. It's not a turning point, but I like to think of it sort of like the turning point because it matches the p and the q idea. P to doing with the x moving left and right, and q moving up and down. So let's go. Y equals, they've given us a over x minus p plus q. I think the hyperbola is almost easier because it's going to be really one way to do this given the information we've got. The p value has to do with the x going left and right. So let's start with that. A over x minus something plus something else. Well, it's moved right by 1, so it almost feels like the opposite. So it's minus 1. It's subtracting 1, and 1 is that value. That 1 just fits in right there, 1, but it kind of feels like that opposite here, if that makes sense. And then our q value, well, q value is how much it's moved up or down by. And it's got y, so it's got to the y value, it's moved down by negative 1, so it's moved down by negative 1. Okay, we've got a point hiding there. It's a nice question because it almost looks like we've been given no other information. But we have. There's the information right there. It's going through the origin. So it's going through the point 0, 0. Okay, so let's substitute that in. I'm going to be nice and say sub 0, 0, explaining what I'm doing. Okay, well, y is 0 equals a over x is 0 as well. Minus 1 minus 1. Let's make that a nice. Okay, let's keep solving this. 0 equals a divided by negative 1 minus 1. Okay, so let's add 1 to both sides of the equation. 1 equals a divided by negative 1. Now we just need to multiply that by minus 1, so those will cancel. What you do on one side, you do on the other. So negative 1 times 1, I'm going to go up here. Negative 1 equals a. Great stuff. Does that match with what we're thinking? I didn't ask at the beginning, does it look like a would be positive or negative here? Well, if it's positive, and again, I'm going to reference, I know some of you, and I got that feedback to you only this evening being Thursday evening, so you still probably need to look at it. The positive hyperbola is in the top right quadrant 1, and the bottom left. Because up here, everything's positive. So that's what that is. And this one here looks like it has been reflected because it's not top right, bottom left. It's been reflected. So we're expecting a negative a. Cool, let's sum it all up. Y equals, our a value is negative 1 over x minus 1 minus 1. It's quite a lot of minus 1s in there, right? Okay, let's move slowly on to our last part. Example 3. This is quite a bit more involved. We've got two functions we need to find. Straight line and a parabola, and they don't give us the turning point this time. So we can't just use that nice turning point form, because that really feels like, to me at least, the easiest way. Just go x minus turning point plus q, sub in a value. Let's start with the straight line. I'm going to do the straight line up here. Y equals mx plus c. Now, we've been dealing with straight lines for a few years, right? C relates to the y-intercept. There it is. So y equals mx minus 10. The whole thing's been shifted down by 10. Mx plus c, mx, they've got plus k. You could have said plus q. Doesn't really matter. Maybe I shouldn't use c because there's a c over there. So I'm actually going to call it plus q. But it's moved down by negative 10. That part we do quite easily. Well, we need to find our gradient. Gradient equals, when you're saying it before I finished asking the question, gradient equals rise over run. So rise over run. We're going from this point to this point. So how far are we running? Now I start with the run. Just always like to keep starting with the x's. So we're going from negative 5 to 0. We must have run across by 5. How far have we risen? Well, we've gone from 0 and we've gone down to negative 10. So we've risen negative 10. That same question I keep asking. What are we expecting this to be? Is the gradient a positive gradient or is it a negative gradient? Well, it's a negative gradient. So at least we're not too baffled when we see a negative come out. So that's negative 2. So y equals negative 2x minus 10. Okay, things are looking good. Let's not do that. Okay, maybe those lines want to stay there. They're being persistent. Okay, so we got our straight line. Now let's look at our parabola. Now this parabola has said y equals ax squared plus bx plus c. We need to find a, b, and c. There's no ways we can start substituting. You could substitute all three values and get three simultaneous equations. That sounds like a daft idea to me. And really, that's not what we're going to be doing. We can't substitute this turning point. As I said, it would have been beautiful if we had the turning point, but we don't. So we're going to have to do this a different way. And this is new, but it's hopefully going to make sense in what we're doing, because it kind of fits in with what you were doing when you had to find out what the x-intercepts were. Remember, you got given it in that other form and you had to determine what those x-intercepts were. We ended up by factorizing, didn't we? So we factorized and we knew that it was x minus something else, and those were like our x-intercepts. That's what we did in those previous questions. I'm not even going to scroll up and get distracted by going up and going. That's what we did. We factorized because we said this equals 0 to find out what our x-intercepts were. Okay, so we're using a similar strategy. All we need to do is say that our general form of our equation can be y equals a times x minus the one x-intercept, x minus the other intercept. So let's put this in and then try and make sense of it. Y equals a, x minus the one intercept, x minus the other intercept. So our one intercept is at negative 5, our x-intercepts. That's what we're dealing with here. So we're going to subtract negative 5. Well, that's the same as adding 5. Minus 5. Okay, and then we're going to, on our other side, we're going to subtract the other intercept. So we're going to subtract 1. Okay, let's see why that makes sense. If we substitute in one of these intercepts, our output should be 0, right? Look, our input's negative 5, our output is 0. Well, our input is 1, our output is 0. So let's substitute negative 5 into our equation as it stands at the moment. Negative 5 plus 5, that's 0. 0 times anything is 0. So if we substitute it in x equals negative 5, our output would be 0, which makes sense. If we substitute it in 1, what would happen here? We'd expect our output to be 0. Well, we substitute 1, this bracket here is 6. A times 6 times, what would this bracket be? 1 minus 1, 0. So a times 6 times 0, our output would be 0. So it fits in quite nicely. And as I said, you ended up by factorizing at the end when you're drawing your parabolas right at the beginning of this section. So we're just doing that again, just in reverse. Okay, Then we need to work out what A is. What does it seem like we've been doing most of the time? Well, we've just been substituting in a value. Well, here's another value that's on the parabola. Yes, it was on the straight line. It's on the parabola as well. So let's substitute it in. We're going to sub in the value, or at least the point, 0, 10. 0, negative 10, right? Okay, so y is negative 10 equals, A, we don't know what it is yet. Our x value is 0. Okay, 0 plus 5. And 0 minus 1, so where we saw an x, we replaced it with 0, because that's what we're subbing in. Okay, so this equals, let's scroll down a little bit here, just keep that in view. So negative 10 equals A times 0 plus 5, well that's 5. 0 minus 1, that's minus 1. So that's negative 5A. That's negative 10. What do we need to do here? Let's divide this side by negative 5. So those cancel and we have A. What do we do on one side? We do on the other. Negative 10 divided by negative 5. 2. A is 2. What do you think I'm going to ask? Does it make sense that we have a positive value of A? Is it a happy parabola? Yes. Okay, doesn't mean that we got the perfect value of A, but it means that we're definitely not way off if we had a negative. Okay, so let's finish that off. A equals 2, so we can put it in here and go, well, y equals 2, x plus 5. So I'm using this equation and going A is 2, x plus 5, x minus 1. And what did it ask for? Did it say determine the values of A, B, and C? Okay, so we just need to do a little bit of work because we haven't shown what A, B, and C are. So we'll need to multiply this out. I like multiplying these brackets first. So let's move this down. Ooh, not that much. Y equals 2, x times x, x squared, 5x minus x plus 4x, 5 times that minus 5. So y equals 2x squared plus 8x minus 10. So therefore we know that A equals 2, B equals 8, and C equals negative 10. Does that fit? Yeah. So there we go. That's finding the equation and this last little bit that we've learned new. But as I say, it's not brand new because you were using this factorization idea. Okay, hopefully that's somewhat helpful. I must write down which questions you need to do from exercise 6.3. I'll add that to this document as soon as I finish this recording, so it's ready to you. But it's going to be exercise 6.3. This is on page 140 and into page 141. And as I said, please, please, please keep that feedback coming. It's really useful to kind of hear what's working, what's not. Yeah, I know that we're kind of struggling through as well, but I know that we would be in the classroom and we'd be loving struggling through it as well, wouldn't we? I mean, this is just great stuff. So well done. I mean, really, each one of you just brought in something that's beautiful and lots of learning and understanding. So let's keep that up and let's work through this. This is our Friday, into the weekend, catch our breath and into another week. I know it's been a long week. I've felt it as well, I must be honest. It's 9 o'clock now on Thursday evening, but I don't know. It's learning, and don't we just love learning? Okay, stop being corny, right? Okay, cheers.